Hello. In this video, we're going to look at factoring, which is going to be the main focus of Unit 3. Now to start, we're going to factor just a basic degree 2 polynomial. Here we have x squared plus 5x plus 4. Now if you remember from grade 10 and 11, our goal here is to find two numbers that multiply to give 4 and add to give 5. Now it's easier to look at the multiplication aspect because only two numbers, or two sets of numbers multiply to 4. 1 and 4, and 2 and 2. Now 2 plus 2 is not 5, but 1 plus 4 is 5. So it looks like 1 times 4 is 4, 1 plus 4 is 5. And so our factored form is going to be x plus 1 and x plus 4. We can check that this is indeed correct by expanding. So if we go ahead and expand this, we'll have x squared plus 4x plus x plus 4, which is x squared plus 5x plus 4, which means we factored it correctly. Now, what I want to do is dig a little deeper into this factoring by actually setting this equal to 0. And so if we imagine this equation was equal to 0, we could have x plus 1 equals 0, and x plus 4 equals 0, and we'd actually solve for x, getting x equals -1 and x equals -4. Now what that means is if we took the number -1 and we treated this like a function, fx, we could plug in the number -1, and we would get -1 squared plus 5 times -1 plus 4, which would be 1 minus 5 plus 4, which would be 0. In other words, x equal to -1 is the special number that when you plug it into the polynomial, it makes the polynomial 0. And you can try over here if you want, x equal -4. Go ahead and pause the video and try to plug in -4 and see what you get. All right, hopefully you gave it a try. If you plug in -4 into the function, you should get -4 squared plus 5 times -4 plus 4, which will be 16 minus 20 plus 4, which is also 0. Again, showing that x equal to -1 and x equal to -4 are the special numbers that make the polynomial 0. And in fact, there's not going to be any other numbers. If you tried x equal to 3 or 4 or 5 or even -2, none of those numbers will work. There's only two numbers that make the polynomial 0. Now let's try looking at a more complicated factoring question, something like this, x cubed plus 2x squared minus 5x minus 6. Well, here we can't use the traditional factoring techniques because, sure, maybe you could find two numbers that multiply to -6, but are they supposed to add to 2 or are they supposed to add to -5? We can't really use that style of factoring. But if we knew the numbers that made the polynomial 0, we could kind of reverse engineer the factoring. What do I mean by that? Well, let me try a number here, like maybe x equal to 2. If we plug that in, we get 2 cubed plus 2 times 2 squared minus 5 times 2 minus 6. That'll be 8 plus 8 minus 10 minus 6, which is 16 minus 16. Oh, hey. That gives us 0. So by figuring out that x equal 2 gives us 0, we know one of the factors has to be x minus 2. Now, if you try x equal to -1, you'll also get the same kind of pattern. -1 cubed plus 2 times -1 squared minus 5 times -1 minus 6. That'll be -1 plus 2 plus 5 minus 6, and that should be 7 minus 7, which again is 0. So one of the factors has to be x plus 1. Now I'll give you a chance here to try to find the third number. You need to try some values for x, and I'll give you a hint. It's a negative number. Try a couple negative numbers and see if you can find one that plugs in to give you 0. All right, hopefully you gave it a try and found x equal to -3 works out. When you plug in x equal -3, you get -3 cubed plus 2 times -3 squared minus 5 times -3 minus 6. That'll be negative 27 plus, well, 2 times 9 is 18, plus 15 minus 6. And in the end, that works out to 0. So that means the third part is going to be x plus 3. Now, maybe you don't believe me. You think this is a little mysterious. How could this be the factored version? Well, we can simply expand out to make sure that this is indeed the factored form of our polynomial. So we get x squared plus x minus 2x minus 2. Then we're going to simplify before we multiply again. So this is x squared minus x minus 2 times x plus 3. Then we'll go ahead and multiply this out, giving us x cubed plus 3x squared minus x squared minus 3x minus 2x minus 6. So that should be x cubed plus 2x squared minus 5x minus 6. Look at that. It checks out. And so this is indeed the factored form of our polynomial. But this is starting to be a little bit, well, it's a lot of work. We have to keep guessing at these numbers, and it might take a long time to keep guessing at the x equals 2 or -1, -3. How could we find a faster way of doing this? And unfortunately, there's kind of a good news, bad news here. The good news is that you can find a faster method for doing this, but the bad news is there will still always be a little guess and check on the front end. So let me show you. Let's say we found the x equals 2 with guess and check. We could use that to finish factoring the polynomial. We wouldn't have to guess at the other two numbers. I'll show you how. We're going to take that polynomial, and I'm just going to move it over here to the side. We're going to write the original polynomial. So we have x cubed plus 2x squared minus 5x minus 6. And what I'm going to do is I'm just going to drop the x's and keep the coefficients. So there's a 1 in front of the x cubed, a 2 in front of the x squared, a minus 5 in front of the x, and a minus 6. I'm going to draw a little line like this, and I'm going to take that number, x equal to 2, and I'm going to put the 2 right here. Now this is called synthetic division, and what it does is it allows us to use that x equal to 2 to reduce the degree of the polynomial. Let me show you what I mean. We have to take the number 1 first and drop it down. That's going to give me 1. Then we have to multiply the number 1 by the number 2 up here, and that will give me 1 times 2, which is 2. I drop down again, and this time I have to add the 2 that I encounter along the way. So 2 plus 2 gives me 4. I multiply with the 2 again, and I get 2 times 4, which is 8. Again, I add going down. -5 plus 8 is going to be 3. I multiply across again. 2 times 3 is 6. And finally, I add down one more time to give me 0. Now, it's very important that I get a 0 in the corner. That's because when we plugged in the 2, the polynomial gave us 0 overall. So this means that we have a new polynomial, 1, 4, and 3. In other words, a constant term of 3, 4 for the x, and 1 for the x squared. And in front, I know x minus 2 was the other factor. So what we've done is taken a polynomial of degree 3, and we've done what's called synthetic division to reduce it to degree 2. Why is this useful? Well, this last polynomial here of degree 2 is super easy to factor. We use our regular skills from grade 10 and 11. Two numbers that multiply to give 3 and add to give 4 looks like x plus 1 and x plus 3. We have our x minus 2 in front, and we're done. We finished factoring our polynomial and only had to guess at one number. All right, so let me give you one to work on here. We have x cubed plus 5x squared plus 2x minus 8. I want you to try to factor this using that shorter method. So what I want you to do first is find a number that when you plug it in gives you 0, and then I want you to try to follow those synthetic division steps to reduce the polynomial and then factor it like normal. Go ahead and pause the video and give it a try. All right, hopefully you gave it a try. The number that works is x equals 1. So if you take the number 1 and plug it in, you should get 1 cubed plus 5 times 1 squared plus 2 times 1 minus 8. That'll be 1 plus 5 plus 2 minus 8, which is 0. Now, if you weren't able to get the number that plugs in, now that you see the number 1, go ahead and try the synthetic division and see what you get. But for those of you who got this far, let's keep going. We take our polynomial and we write out just the coefficients. So again, we had x cubed, 5x squared, 2x, and 8. So we get 1 for the x cubed, 5 for the x squared, 2 for the x, and negative 8 for the constant term. We draw a little L, and we write the number x equals 1 in the corner. Now again, the steps here are the same each time. We go ahead and add down, and then multiply. So 1 times 1 is 1. We add down, 5 plus 1 is 6. 1 times 6 is 6. 2 plus 6 is 8. 1 times 8 is 8. Negative 8 plus 8 is 0. So that means x minus 1 is our first factor. X squared plus 6x plus 8 is our reduced polynomial. That's a lot easier to factor. Two numbers that multiply to give 8 and add to give 6. That looks like x plus 2 and x plus 4. Again, if this factoring feels a little bit mysterious for you, go ahead and expand this out, and you should get back to where you started. Now, the best way to get good at this synthetic division and this factoring is to just practice a number of examples. So here we have another polynomial, x cubed minus x squared minus 14x plus 24. And again, you're going to need to find a value that makes the polynomial 0, do synthetic division and work it out. So go ahead and pause the video and give it a try. All right, hopefully you found x equal to 2 works. If you found x equals 3, that also works. There's multiple values, but as long as you find 1, you'll be good to go. You write out the coefficients of the polynomial. You put the 2 in the corner, and again, you add down, and then multiply back up. Add down, multiply up. Add down, multiply back up. Write your reduced polynomial, and factor it like normal. In this case, it should be x plus 4 and x minus 3. And don't forget that this 2 gives you your front factor of x minus 2. All right, here's another example for you guys to try. Go ahead and pause the video and see what you come up with on this one. All right, this one is x equal to 2, also works. But it's a bit tricky when you write out the L. There's a 1 for the x cubed, but if you notice, there's nothing here for the x squared. In fact, it's almost like there's a 0x squared, and so we have to put a 0 in our synthetic division, like a placeholder for the x squared term. Then you put the minus 3 for the x and the minus 2 in the end. So again, we're going to work with the 2 here. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. Adding down gives 1, back to 2, and 0 in the end. So you get x squared plus 2x plus 1 with the x minus 2 in front. And that factors down to x plus 1 with, again, the x minus 2 in front. Or if you want it to be fancy, you could write this as x plus 1 squared. All right, now here's another one to try. This one's a bit tricky, and so please use your calculator when trying different values of x to see what gives you 0. I'm going to give you a hint. You need to use a negative number for x. All right, go ahead and pause the video and give it a try. All right, hopefully you found x equal to either negative 3 or negative 4. Let's say you found x equal to negative 3. We go ahead and set up our synthetic division. Put the negative 3 out in front. 2, negative 3 times 2 is negative 6. 9, negative 3 times 9 is negative 27. 4, negative 12, and 0. So you get x plus 3, 2x squared plus 9x plus 4. Now this polynomial is still relatively easy to factor, but we do have to use some skills from grade 10 and grade 11 called group factoring. So if you don't remember how that works, we need to find two numbers that multiply to give not 4, but two numbers that multiply to give 2 times 4, or 8. We have to include that leading coefficient. And then we need to find two numbers that add to give 9. Again, it looks like the numbers are going to be 1 and 8. And so what that means is the middle term gets split up into 1x and 8x. So we now have a polynomial that looks like 2x squared plus x plus 8x plus 4. We look for those first two terms and we find that there's a x in common, leaving us with 2x plus 1. We look at the next two terms and find that here we have a 4 in common, leaving us with 2x plus 1. And now we look and notice that there's a 2x plus 1 in common with both terms. So we factor that out completely. And we have left x plus 4. And we factored our polynomial. Of course, we don't want to forget that in our final answer, we should include the x plus 3. Now, if this group factoring is a bit tricky for you, I'm going to show one more example. Here we have 6x squared minus x minus 2. Again, trying to review this concept from earlier factoring classes. We would take this 6 and the negative 2. 6 times negative 2 will give us negative 12. So we're looking for two numbers that multiply to give negative 12 and two numbers that add to give negative 1. So I'm thinking those numbers are going to be something like negative 4 and 3. So the middle term here gets split up to negative 4x plus 3x. And then we still have the negative 2 and the 6x squared. Then you always group up the first two terms, and you look for what's in common. It looks like a 2x, leaving you with 3x minus 2. Now the second two terms don't really have anything in common, so they have a 1, 3x minus 2. You factor out the 3x minus 2, and you're left with 2x plus 1. All right. Here's one last example for you to try. I'm not going to put the answer because it is a little bit tricky, and I want you to really wrestle with this problem. I will give you a hint that you need to use your calculator because the numbers are quite large, and the x value is going to be negative. Now, it's not going to be a huge negative number, but it will be a bit larger. It's not like 2 or 3. It's kind of like 5, 6, 7, 8, somewhere in there. So one of those negative values will work. And then you can use your synthetic division to finish off the rest. If you're still struggling with it, I would highly recommend you go to one of the websites like Wolfram Alpha or another online software, and it'll show you how to do the steps, maybe even something like PhotoMath. But before you check a website, please try to factor it on your own using a negative x value and, of course, checking which ones work with your calculator. All right, I hope that makes sense. Now that you've completed the lesson for lesson 1, you can try Unit 3 Worksheet 1 and 1.5. Thanks for watching.